notes for review of Algebra 1 factoring. In these next two videos, we are going to be reviewing factoring. This is something that you should have seen in Algebra 1. If not, make sure that you read through the notes and go through the notes carefully. Make sure that you come and talk to me and ask any extra questions if this is something that you're not familiar with. Also, you may have learned factoring a little bit different than the way that I'm going to explain it to you. If you have a better way that you learn, that you remember, that you like, by all means use that way. Just make sure that you're still coming up with the same answers that I am, so make sure that your method is working. So the first thing I want to do for lesson 1 is to think about the distributive property. This is something that we talked about at the beginning of the year as well. When we distribute, we're multiplying the number outside the parentheses by everything inside. So we're first going to multiply 2 times x, which is 2x, and then 2 times 3, which is 6, and we add those together. Factoring is just the opposite of that. We're factoring or dividing out that 2 and putting it in front of our parentheses. So again, factoring is the opposite of distributing or multiplying. So the first form of factoring is factoring out a common factor. So when 2 or more numbers are multiplied, the result is a single number. Factoring is the reverse process. In factoring, one begins with a single number and expresses it as a product of 2 or more numbers. This process also works for polynomials. So again, we're factoring or dividing out a common factor. Example 1 says to find the greatest common factor. So we are looking at 36x and 45x squared. So again, we're looking for factors or things that we multiply together to get 36x and 45x squared. So let's first think about 36 and the factors of 36. So we have 1 in 36, 2 times 16, 3 times 12, 4 times 9, and 6 times 6. And then we also can't forget our x. So these are all the factors of 36, things that we can multiply together to get 36x. So next we need to look at 45x squared. So we have 1 and 45, 3 and 15, and 5 and 9. And then with x squared, we know that that's x times x. So we're looking for the greatest common factor, so the largest number that they have in common and the largest amount of variables that they have in common. So for this one, we have a 9 in common, and we also have 1x. So our greatest common factor is 9x. For example B, we're going to do the same thing. So we have 7a to the 4th b squared, 21a cubed b to the 4th, and 49a squared b cubed. So 7a to the 4th b squared. The only two factors we have are 1 and 7. And then we have a to the 4th, which is a times a times a times a, and b times b. For 21, we have 1 and 21, and 3 and 7. We have 3 a's and 4 b's. And then lastly, 49, we have 1 and 49, and 7 times 7. We have 2 a's and 3 b's. So again, we're looking for common things that they have. Notice they have a common 7. They also have 2 a's in common and 2 b's. So our greatest common factor is 7a squared b squared. And when we're looking at exponents and variables, we're looking for the greatest common factor. It's going to be the lowest exponent that they have in common. So if they have a variable in common, so for instance a's, we're looking at all of the a's and finding the smallest exponent, which we know is a squared. So that's going to be our common factor for our a's. Example 2, we're factoring the polynomial completely. So again, we're first finding our greatest common factor, and then we're factoring it out and writing what is left over. Again, think of factoring as dividing. What can we divide out of each of these? So let's start with the first one. I like to think of this again as division. So we're going to look at what they have in common. Notice they both have a y. So the first thing we're going to do is divide out a y. So what we have left is 7. Remember, y squared is y times y. So if we divide out one of those y's, we're left with 1y. Plus 3, and then y cubed divided by y to the first is y squared. Now notice they still have a y in common. So we can divide again by y. So if we divide out a y, 7y divided by y is just 7. 3y squared divided by y is 3y. Our factored answer is we multiply what we have divided out, so this is going to be y squared. And then inside the parentheses is 7 plus 3y. Now we can check our answer by distributing. So if we distribute the y squared, we get 7y squared plus 3y to the third power, which is exactly what we started with. So this is our final factored answer. Now if you can see that they have a y squared in common, by all means the first step you can just divide both y's out and you should end up with the same answer as well. For the next example, we're going to go down to part B. Now the first thing that I noticed that these have in common is that they are all even numbers. So 4, 50, and 10 are all even. So I'm first going to divide out or factor out a 2. That leaves me with 2a squared bc minus 25ab squared d plus 5ab d. So that's the first step. Now I want to look at my variables. I notice that they all have an a, so I'm going to factor out an a. So if I, again, divide out an a, we get 2a squared divided by a is just a, and I still have bc, minus 25, a divided by a is just 1, so those are gone, b squared d. And again, for the 5, we divide out the a's, so we're just left with 5b d. And the other thing I noticed that they still have in common is a b. So then I'm going to divide out the b. So I'm left with 2ac minus 25bd, because one of our b's cancels, plus 5d. Now I notice they don't have anything else in common, so this is going to be my final answer. So I have 2ab, because that's everything that I divided out. I'm left with 2ac minus 25bd plus 5d. So that's my final factored answer. Again, I can check it by distributing. Should end up with the same thing that we started with. Let's go up to part C. Again, I'm going to look at my numbers first. I have 39 and 24. I know that those are both divisible by 3, so I'm going to factor out a 3 first. So I get 13m cubed minus 8m squared. Now we notice that they both have an m squared. Now you can factor out m's on their own, but I notice that they have 2, so m squared. So this leaves me with 13m minus 8. So again, my final answer is 3m squared, and 13m minus 8 is in my parentheses. Again, if you notice from the very beginning that 3m squared is their common factor, by all means factor it out all at once. If you want to do it step by step, there's nothing wrong with that either. So my final answer, 3m squared times the quantity 13m minus 8. Now for part D, I want you to think about what common factors do 5x and 1 have. Notice that 5 and 1, the only common factor that they have is a 1. And both terms do not contain an x, so there's nothing that we can factor this out. This one cannot be factored. So not all polynomials can be factored. If it can't be factored, we sometimes will call it prime. So again, the first step in factoring is looking for a common factor and dividing that out. Example 3 says to simplify. Notice that we have some fractions here, and we are simplifying by dividing out what's in the denominator. So for part A, notice we have a polynomial, or more than one term on the top, and we have one term on the bottom, or a monomial. So what we can do is we can divide each of these terms in the numerator by the term in the denominator. So this will become 7st squared over 7st plus 14st over 7st minus 49s squared t over 7st. And then we can just simplify. The 7's cancel out here, s's cancel out here. T squared divided by t. Remember, t squared is t times t. So one of those t's cancels out. We're just left with 1t. For the second fraction, 14 divided by 7 is 2. Our s's and our t's cancel out. And for the last fraction, we have 49 divided by 7, which is 7. S squared divided by s. Remember, s times s is s squared, so one of those s's cancels out. We're left with just one s, and then our t's cancel out. So our final polynomial is t plus 2 minus 7s. For part B, we can do the same thing. So m to the 12th over m to the 5th plus 3m to the 9th over m to the 5th minus 4m to the 7th over m to the 5th. M to the 12th over m to the 5th. Remember, we can subtract the exponents. Again, if you wrote it out, 12 m's and 5 m's in the denominator, 5 of them will cancel out. So we are left with m to the 7th plus 3m to the 9th over m to the 5th would be m to the 4th minus 4, and then m to the 7th over m to the 5th is m squared. Now we have to look at our answer, because if you notice, we have a common factor that we can factor out just like we did on the previous page. So notice they have an m squared in common, so we can divide out an m squared. We are left with m to the 5th plus 3m squared minus 4. And again, this is m squared times what's in the parentheses. So our final factored simplified answer is right here. So again, whenever we're dividing by one term, we can split up the numerator so that each of them is divided by that term that's in the denominator. For the next section of notes, I want you to think about multiplying polynomials. So I want you to look at part A and part B. I want you to pause the video. I want you to multiply and simplify and look for a pattern. Once you have finished part A and part B, I want you to answer the two questions. Now, some of you may have heard the term FOIL before, and that is when we're multiplying two binomials. We multiply the first, outside, inside, and last. If you haven't heard of FOIL, again, just think of the distributive property, because that's how we would multiply these polynomials. For part A, you should have gotten x squared minus 9. For part B, you should have gotten 9a squared minus 25b squared. Now notice on the outside and inside terms, so that would be your 3x minus 3x and your 15ab minus 15ab. They are opposites, so they're going to cancel each other out. For the second part, what do you notice about the first and last terms of FOIL? So that's going to be your x squared and your minus 9, your 9a squared and your minus 25b squared. Now you should notice that these are perfect squares. So things such as 9, so 3 times 3 is 9. 4, 2 times 2 is 4. So you're looking for perfect squares. So the next way of factoring is if you have a difference of two squares pattern. So you're looking for two perfect squares being subtracted. The key term here is that they are subtracted. If they're not subtracted, then they're not perfect squares, or it's not the difference of two squares, so you cannot factor with the pattern that I'm going to show you. Then it factors as the sum and difference of the square roots. So if we take the square root of a squared, it's going to be a. The square root of b squared is b. So we're going to add, so a plus b, and we're going to subtract a minus b. Again, if you multiply these out, you'll see that your middle terms, your ab's will cancel out because one will be positive and one will be negative. So if we look at a, b, and c, we are looking for perfect squares. So I'm going to give you a list of perfect squares or numbers that we should be looking for. So for example, 1 squared is 1, so 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, so 9 is a perfect square, and so on and so forth. So I've given you a list from 1 to 12 of perfect squares. Again, these are numbers that you should begin to recognize as perfect squares so that you don't have to check all of them all the time. So if we look at part A, we have 4x squared minus 1. Notice 4 is a perfect square and 1 is a perfect square. So we're going to take the square root of 4x squared. So that's going to be 2x. And the square root of 1 is just 1. So our factors are 2x plus 1 and 2x minus 1. Again, you can multiply it out to check your answer to make sure that you get the correct answer. Part B, we had 25x squared plus 81. Notice that 25 and 81 are both perfect squares. However, the key here is that we have addition. If it's addition, our pattern will not work. It must be subtraction, so this one cannot be factored. Our last example, we have 25m squared n squared minus 16. Notice that 25 and 16 are both perfect squares. Also, m squared and n squared are perfect squares because m times m is m squared, n times n is n squared. So if we take the square root, so 25m squared n squared is 5mn, and the square root of 16 is 4. So our factors are 5mn plus 4 and 5mn minus 4.